Today I'm going to be talking about performance and about how to improve the performance of navigations on your application. Here's the deal. We all are Angular developers, and we work on real applications, not just a website that is a landing page, which means there is a minor difference to the way that this works. And so the main thing is, on an actual application, a user spends his time interacting with the website, not just loading it. So for some weird reason, we only focus on this kind of initial load and how fast do we get to actually display something on the screen, when that's not what your user's there for. He's there to actually interact with your application and do things on it. And so we can see that Crux data is showing us that 90% of their time is spent actually doing things on the website. So navigations and interactions as such. Today, I'm not talking about the first navigation. I only talk about future navigations, the secondary navigation on your website for single-page applications. And I hope to show you how to go from the image you see above, where it takes about 2 seconds to navigate to a different page, to something that it takes about 100 milliseconds to actually navigate. So it's a huge, huge difference. Michael already introduced me, but I am Chris. I focus on performance and user experience, particularly today, talking about how to make the secondary navigations blazingly fast. My Twitter is ChrisPHolder if you're interested, and I'm a software engineer, trainer, and consultant specialized in performance. So let's get into the actual topic. Usually, you think about how do you measure something like this? How do you measure actually navigation performance? And we have a golden standard for this. It's LCP, largest contentful paint, right? It doesn't exactly measure how fast your application loads, right? It's just kind of a user perceived. I love how the red that is supposed to highlight the colors of the important pieces is removing them. It's a perfect touch for this. So essentially, it measures user-centric. It's a user-centric metric to tell you how your user perceives the speed of the application, the speed of the navigation. Doesn't really measure speed. It actually just measures the largest piece of content. You're probably familiar also with the estimated amount of time, under 2.5 seconds is good. Between 2.5 and 4 seconds is kind of an okay, but it needs improvements. And over that, it's actually getting pretty bad. And fortunately, we also have a little cheat sheet or framework that we can use to think about how do we optimize the largest contentful paint on a page. Essentially divided into 4 parts. How long does it take for the server to actually send you some data? After that, how much needs to happen so that we actually start loading that important resource? The important resource could be an image, could be a piece of text. To simplify it, in this case, we're just going to use an image as the largest contentful paint. And of course, maybe your use case has something slightly different. It is the most important resource on the page. Finally, whatever additional time it takes to actually render it on the screen once the resource is already loaded. But you might have noticed something already. In a multi-page application, that totally makes sense. How long does it take for the server to respond? And then you actually load the content and everything. But in a single-page application, we don't essentially load a new resource every time. We don't load a new HTML document. And so therefore, this metric doesn't really work, and it doesn't really handle our use case. That does not mean we cannot measure it. There is an experimental feature called soft navigations. Soft navigations is a way to actually measure core web vitals, but focusing on multi-page applications, single-page applications, sorry. Essentially, it allows you to get the same type of metrics you would usually get, your core web vitals, but also for subsequent navigations. Now, what is a soft navigation? A soft navigation essentially means we render a user clicks on something, we render a new piece of content, and we switch the URL itself. There is an actual change to the history API showing that there is an actual rendering change, and it can be considered a navigation, even though it's a soft navigation. It is experimental, but it is in its second trial. You can try it out on your browser, and I'll show you it on the demo. And so here is the major change. Essentially, the first block that we'd seen in our framework is kind of gone. We no longer have this first input, this first byte, because the HTML document has already loaded and we're not loading a new one. Essentially, most of our navigations will look something a little bit like this. where, you click on a button, then we load something related to a route, some additional bundles that need to be loaded, fetch some new data, and then load the actual element and then render it on the page. Essentially, as you can see, that would be more or less a visual of what that transition looks like. I don't like to reinvent the wheel. And so I'm very fortunate that there is already a way to focus on improving these secondary navigations for the websites. This is something called the Speculative Rules API. Essentially, it allows you to pre-render and preload and do some additional work behind the scenes to load and create some additional resources so that when you interact again on the page, it will load the next part faster. Unfortunately, this is not for single-page applications. It targets actual documents and does everything specifically for multi-page applications, so it's not for our needs. It's also experimental and not available everywhere. So you can see, for example, that it's still not available on Safari or Firefox, so even if we were able to use it in single-page applications in Angular, it wouldn't really do the trick as it is not available in Safari and Firefox. But there are custom implementations of it that allow us to do some part of the actual work behind the scenes in just using JavaScript that would allow us to make it work on all different browsers. For example, quick links, and specifically NGX QuickLink, which is a library developed by Minko Getchev, which essentially allows you to identify which routes are possible, which links are available on the page that could lead to the next navigation. So essentially, we would be able to preload all additional bundles that would be necessary for the next navigation. Essentially, getting rid of this initial part where we are going to load all the bundles related to the route and then be able to fetch the data, which visually speaking usually would be something like this, or some additional type of loading spinner during the transition. Already a very, very large improvement. Also means that your website will react much, much faster to this transition, right? Now you can actually see that we have an immediate reaction. We start loading the route, visual change, we render something on the screen, fast and beautiful. But we still can improve further. We still can go ahead and think about loading the critical data on the website. So what data is going to be necessary to be able to load the next piece of content on the page. And for that, we can take advantage of the Angular router, right? We can go ahead and match the actual routes that we're going to use with specific links and figure out which resources we're going to need in advance and use this concept that we call pre-resolvers. Pre-resolvers are essentially functions that you can run as part of your route so that when you have a link on the page that will match to a future route, you can go ahead and just run a function, get some data. This usually would mean instantiating some type of cache, initiating some type of request that might have some HTTP cache or any type of state that you might want to handle in the background as a side effect. This, of course, runs inside the injection context, which means that we can either run it from the injection context of the route itself or just the root injection context, allowing you to actually use services and not just functions for your application. And that will target these two new spaces. Now you have a situation in which the data is already there, so we're not having to display an additional loading spinner or an additional empty space, but we can go straight into actually rendering the elements. I still left the white space there, and I'll explain why in a second, and that has to do with like general rendering performance. But I will show you that in a moment. Of course, that leaves us with the last item. We still have the actual element itself, the image or whatever is necessary in that case, and we, of course, have some native browser implementations that we can actually use to load that in advance. For example, we can go ahead and just inject a link tag to preload the image, get it ready before time. The implementation might require to do some special patterns to actually get the size that you want to display. But essentially, you can just add a link tag that will allow you to preload the actual link, the actual image before time, and get it ready on the browser. This means that we now would get rid of this additional loading period where the image is being displayed, essentially being able to render it directly on the screen with the addition of this rendering delay, element render delay. And so for that part, you actually have to focus on how do we go ahead and optimize the rendering of Angular itself, and how do we render the items faster. I am not really going to go very deeply into that. There is an awesome talk from Julian, RMC here, who's also the guy who started the implementation of the speculative links that we have here. The QR code will send you to a YouTube video, so it is online. You can check it out from, I think, NgDE, so it's already there. NgDE, yeah. And of course, if you want to try out the actual repository, the library, to be able to improve rendering performance of your application, we have here a link to RxAngular. So let me actually show you how this looks like in practice, show you a little demo, and show you some of the internal details there. We have this beautiful Angular application. Let me go ahead and just show you what that is. And it's essentially a movies application where we're displaying all the different items, and we have multiple different routes. This is just going to be the demo application that I use, but of course, the implementation doesn't require these specific things. First of all, we need to configure the router to actually preload the important information there, the specific routes. Here we can use the speculative link route preloader strategy. So you essentially pass it to the router so that every time a link appears on the screen, it will go ahead and actually load the important routes for it. In your actual template, you just have to add the directive to it. There are other ways to do that, but essentially, we go ahead and add the speculative links directive and pass it the URL or the path to the future route that you would be navigating to. Pretty straightforward, and you can kind of just sprinkle this around in your code to actually get it to load different bundles and different routes. And finally, we have the router itself. We have a simple path here, so the list type an identifier, and we're able to extract some of the key pieces of information from that. For example, we can go ahead and extract the parameters from there, so we know that the type, if it's the genre, so it's one of those, or a category page, we can go ahead and execute any specific function. It's a side effect, so we're not really storing something in there or accessing that same piece of data directly through the application, through the component or the router, but we can instantiate the cache that way. And we would go ahead and just load the data and do whatever additional things you want to do, like inject image tags within the router. So if we go back into the demo that we have, this is the actual application. And I'm going to go ahead by just showing you how it looks like without the speculative link preloading. I'm going to go ahead and clear the cache just to get a nice little clean thing. Just reload that for a second there. And you can see that we have the actual application. I told you that we can go ahead and measure the performance of the soft navigations to secondary navigations. And I have this very simple script to do that. It's essentially using a performance observer to log out every different LCP event that happens that are soft navigation specifics. This is done through activating a flag in Chrome itself, so you can actually measure that. Now, I'm going to go ahead and turn on that script, and I'm going to go ahead and throttle the network to a slow 3G network, slow 4G network, right? Essentially representing what a mid-tier device actually is. Now, we can go ahead and just click on a link, and we can see that it took 1.8 seconds to actually load the next page. This is a pretty well optimized application already, so we have focused a lot on minimizing the actual bundles, but you can see that even there, you're still loading additional things, and that is going to take some additional time. Now, if we compare it to the different application that we have here, which is just served locally, go ahead and do the same thing. So let me just go ahead and empty cache and refresh. Going to go ahead and do the same type of network throttling. And first of all, I would just like to show you what happens if we were to, for example, open up a widget. So let's say that here we want to check out the different options, different categories and different pages that we want to see. You'll notice here that on the side, once that loaded, I went ahead and started to load data related to that. So I loaded the potential routes that might be necessary, as well as loading additional data that might be necessary for that. For example, you can see that here. Now, if I was to take a look at the images that are loaded, you would also be able to see that not only am I loading the additional ones here, but essentially from the links that are in place, I'm also loading the future images that would actually be necessary. Let me go ahead and show you what that actually means in practice. So let me clear this so you have a clear view, and we can go ahead and load it. 81 milliseconds. I would say that's a pretty dramatic increase from approximately 2 seconds for a very well-optimized application already to 80 milliseconds. Yeah. If you want to actually see this in a production application, this is currently present on one of our sponsors, which is Intain. Sorry, Michael, you're looking at me. I thought that. So if you actually want to check it out, you can go ahead and take a look, for example, at bwind, where you can actually see that it's activated on certain different navigations. There's also a wonderful article written about this, how to improve the navigations on secondary navigations, so the performance of secondary navigations. And finally, if you actually want to take a look at the implementation, we still have not published a repo. We're still figuring out some of the details. For example, how we should handle guards or redirections inside of the actual pattern matching and what routes should actually load a pre-resolver. But if you want to go ahead and take a look at that, this link should take you to a nice little repo where we have a functioning implementation already. Still discussing some of the additional APIs. If you want to try it out for yourself and give us some input on what we can do better, what APIs you would like us to have there, please let us know. Yep. And that is it for me.